Hello everyone. My name is El Mustafa and this is Comstech Podcast. Welcome. Today we have a special guest, Professor Mohammad Sirajul Islam from Bangladesh.
Thank you too for inviting me for this podcast.
Professor, can you give us a quick overview of your journey from civil environmental engineering studies to your PhD in Tokyo?
Well, actually, I am a civil engineer by profession, so I graduated from Bangladesh University of Engineering Technology in civil engineering. But in civil engineering, there is some specialization. Water resources and environmental engineering is two specialization. So I preferred on that specialization. Actually, in my master's and PhD, I specialized on environment and water related issues. So gradually, nowadays I'm more on water expert and climate change and disaster expert, and not only academic. I also work for UNFCCC, United Nations Framework Convention on Climate Change. I'm involved with IPCC, Intergovernmental Panel on Climate Change. Apart from this, I involved with Asian Development Bank recently on action on climate change in Asia. So, like this, I liked it that I wanted to be a water expert, and I consider myself as a water expert specializing in climate change and disaster management.
What does climate change adaptation mean to you personally, as a scientist, as an expert?
Yeah, actually, before climate change adaptation, to explain, we have to mention the three regimes of climate change. The people in the climate change arena, they involved. There are three group of people involved in the climate change. One people are in mitigation. Mitigation means the proactive approach. Means you reduce greenhouse gas emission, so that global warming cannot happen. Proactive approach. This is called mitigation. Impact studies. This group actually try to understand how temperature rise will affect different sectors like water resources, health, agriculture, and so and so. On the other hand, adaptation is that global temperature has increased. Ice started to melt, river flooding, sea level rise. Then what will you do? And that is adaptation. Adaptation means we have to prepare for the changes and some adjustment is needed to live with the changing condition. Especially for developing countries like us, we are not liable for greenhouse gas emission, but the impact will come to us. And we have to adapt to the changes. And that is what actually adaptation means.
What are major research gaps or technical challenges in your fields are still underexplored?
Yes, actually, still now, especially in water resources sector, what will be the future scenario? What will be the rise in temperature in 2030? What will be the but in 2050, we used to predict it by general circulation model output or GCM output. But GCMs are still not very precise. I cannot say that what will happen, what should be the exact rise of temperature and exact rise of sea level. That's a big challenge. We actually see what's happening and then take precautions. It's okay, some measures, but if we could clearly predict the future, that okay, this is going to be happening, so my road should be like this, my embankment should be like this. Scenarios, the precision of the scenario development. These are a major gap. And of course, more innovations are needed like saline tolerant crop, how to recover land from sea if sea level rise, and how to control flood. This type of things are actually major challenges.
What are the biggest water management challenges in South Asia, especially in Bangladesh and Pakistan?
Well, the nature of water management problem in South Asia is almost same, because South Asia, the rainfall or precipitation, what we say, the precipitation used to take place through the special climatic phenomenon known as Asian Monsoon. And Asian Monsoon is due to the differential temperature between the huge landmass of Eurasia and the surrounding sea. Now, in South, the Asian Monsoon affects South Asia, Asian Monsoon affects part of China and Japan and this part as well. Now for South Asia, what happens? The ER goes from Bay of Bengal or the Indian Ocean or Arab Sea toward north, and then again there is a big mountain range that covers the entire South Asia, the southern South Asia at the southern part of it. It hit the mountain range, go up, and precipitation occurs, and that are the sources of the rivers. Three major big river system. One is Indus River system, the other is Ganges River system, other is Brahmaputra rivers. All of them actually generated in the Himalayan mountain range, and it gets precipitation mostly through Asian monsoon, and there are huge amount of ice accumulated at the top of the mountain. So if global temperature increases, there is saying that ice will melt, Asian monsoon will intensify. So this is how these are some major challenges we can foresee that climate change may cause, aggravate the flooding situation maybe in South Asia, entire South Asia. And natural problem is almost the same.
In Bangladesh and Pakistan.
Yeah, Bangladesh. The main problem with Bangladesh, Pakistan, India, another problem is that their population density is very high. We say that a particular natural event will affect you, depends on how many people are exposed to it. If we live very close to the river, so many people, then the effect will be huge. And this is what another characteristics or similarities of the problem in South Asia. That if the same flood in Europe may not affect so many people, but this flood in Bangladesh or Pakistan affects so many people because people live very close to the river and the density of population is very high. That's a big problem, okay? And then they do not have any understanding what is the danger zone, in a developed country, people usually keep away from the from the river. That, okay, I have to be away from this because this is flood zone. But we do not have such. So more people are prone to disaster. They are unaware and they have to be very close to the river because of agriculture and other purposes. So that's a big issue, challenge for South Asia, for both Bangladesh and Pakistan, I think.
Professor, what is new in the disaster risk atlas methodology that you adopted in Bangladesh?
Okay, in Bangladesh, you might have heard from me or some sources that in Bangladesh we have developed a disaster risk atlas. It means that for different disaster, we have created a map that this particular district is very much vulnerable to cyclone. This particular district less vulnerable to cyclone. This particular area vulnerable to flood. This particular area less vulnerable to flood. This particular area vulnerable to river erosion. This particular less. So the map can give the government officials, the project those who develop the government projects, have an idea that what is the level of risks involved in if I want to build a bridge, or if I want to build a road, or if I am going to build a big building, then what kind of natural disaster I may face. And that disaster risk atlas actually give a preliminary idea about the risks, and accordingly you have to take actions. Government has made it mandatory that every project must be assessed against disaster. And the guidance for this disaster is this disaster risk atlas, that you see your project, where it is located and what are the disasters and how, what is the risk level. The risk level has been classified under 5 categories. Strongly, very strong and up to low. So accordingly you decide the risk level of your project. So this is how the disaster risk atlas is actually supporting people.
Can we scale up flood early warning systems entire South Asia?
Yes, the warning system is a very, very important issue, because in the flood management regime, we say that there are 2 types of management. One is proactive, the another is again proactive and reactive. Proactive means instead of going for hardcore structural measures, we take preparation to fight against or live with flood. Let's say if I have a good warning system, I myself get prepared that okay, flood is coming, and then I shift to some safer place or some other. So warning is very important, early warning. Even if we have a warning nowadays, long range warning, or people are thinking that whether it is possible to say that this year will be flood, or 6 months or 4 months or 1 month before what it is going to be happening. This type of warning can always benefit people. For cyclone warning, it is very much beneficial, but for the case of flood warning, also if you have flood shelter, if you can warn people, especially flash flood area, this might be dangerous and disastrous. People may shift to safer place, save their belongings, especially the valuables, and like this way we can get rid of it and get prepared in a better way.
Professor, tell us some case study of good practice in Bangladesh.
Yeah, good practice in Bangladesh. One, I can say that we have developed risk atlas for the entire country. Also, we have developed a flood forecasting and warning center. It is called FFWC. FFWC in Bangladesh, actually in real time, any part of Bangladesh, there are around 100 stations, and if you just click in one station, it will give what was the water level last few hours or one day, what it is expected in next 10 hours or 20 hours. So some sort of modeling approach. One is the observed data, the other is the modeling forecast. So like this way, it can give you a better understanding of the condition, what is going to happen. I should say, as it is the last question to me, that not only Bangladesh, some other countries have some good practice, like China. China has a very good practice called sponge city concept. The sponge city concept is that cities are nowadays being affected by flood. And this is because of local effect. Local effect means local clogging, because water cannot go anywhere. Water cannot penetrate into the ground. There is no drain. Even if there is no flood in Pakistan, but some cities are flooded. Even if there is no flood in Bangladesh, the cities are flooding. And when a city floods, huge amount of economic loss, because the pavements are deteriorated road pavements. People's working hours decrease, health issues. So sponge city idea, China, what they invented is that they increased the porous areas. That means they kept areas open. They make the parking area porous. They even made porous pavements, and they conserved water bodies. The roads they elevated, and below there they put some drains and some water passageways, so that they absorb after precipitation 50 to 60% or more water absorbed by the soil instead of being runoff and flooding. So that is a big challenge. In developing country like South Asia, our population density is very high. So we are actually covering the entire city, no open space, no pond, no lake, no channels, natural channel, all has been filled up. And China tried to implement reverse it. They also had the problem like this, that no, we have to keep those areas open, and absorption capacity of the city will increase. So these are some good practices I can mention from Bangladesh or elsewhere in the world.
Any comment about your visit to Islamabad, especially COMSTECH?
Yeah, I'm very much hopeful about COMSTECH, because COMSTECH is working in YC countries, and Bangladesh and Pakistan are two most densely populated countries among the YC. Maybe after Indonesia, Pakistan, and then Bangladesh. So I hope COMSTECH will extend its research and other collaboration with Bangladesh as well, especially flood-related issue. Pakistan, Bangladesh both has the same problem. And not only this, water-related problems are very much prominent in YC countries. In South Asia, Bangladesh, Pakistan flood. In Saharan countries, sub-Saharan countries, Egypt, Sudan, Ethiopia,
Mauritania,
they are suffering from drought. So these both are actually water-related problem. How to expedite water availability and how to reduce the excess water. So that can be a very important point of research issue for COMSTECH as well.
Thank you very much, Professor, for this.
Okay, thank you very much too, and I really appreciate it.
Thank you very much.